Welcome to APCUG's Wednesday workshop, where we get together in the middle of the week to learn more about technology. Today, we've got a very interesting topic, as you saw, and that's why probably you're here. Dale Harrington's been with us before, but it's been a while, so I kind of want to remind people about who Dale is and a little bit of his background. Dale enjoys helping senior citizens and younger whippersnappers, and each year that kind of age keeps moving up. He enjoys helping them use and enjoy computers and other technologies productively. Since 1994, he has served on the board of directors for the Mile High Computer Resource Organization, MICRO, a 501c3 nonprofit dedicated to delivering personal computer education. In his role, he has developed course materials, taught introductory computer classes to seniors at local community centers, and presented on numerous technology topics for micro and other user groups across the Denver area. Now, prior to this and continuing through 2005, he worked with Computers in Ministry, where he provided comprehensive technical support to local ministers, managing their networks, internet connectivity, servers, emails, and hardware systems. Going back in time, 1988 to 1994, Dave served as the maintenance department manager for the Raython Support Service Company. He directly managed 92 technicians and supervisors performing contract maintenance services for the United States Air Force Technical Training Operations at Lowry Air Force Base. This extensive leadership role included overseeing precision measurement laboratories, diverse aircraft armament and weapons control shops, ground and aerial photography systems, and various flight line support operations, and taking care of 92 people. Wow. Before his time at Raython, Dale operated as a self-employed contract consultant from 1986 to 1988, successfully co-developing a proposal for training equipment maintenance at 3 Air Force Air Training Command Centers. This followed a dedicated 25-year military career in the United States Air Force from 66 to 86, during which he specialized in operating and maintaining advanced instrument systems, including analog and digital data and reduction equipment, telemetry simulators, digital computers, and satellite tracking ground equipment. So Dave has worked four different kind of lifestyles, and we're happy that he is continuing with us and sharing. Today, his topic is on operating systems and the idea that we didn't know there are so many different kind of operating systems. So Dale, I'll turn things over to you and let us know what all we didn't know.
Thanks, John. I appreciate it. And yes, there are a few more operating systems than I realized, but then I don't know everything. Most of us know a little piece of the puzzle. So hopefully this will help some people put more of the puzzle together. Hopefully you're seeing the main screen at the moment with blinking lights. And that should be recognizable to some of you as a few network switches.
A few.
Doing their work. And by the way, if you see the blue and the yellow connector on there, those of us that had to work on these things hated these connectors because they were hard to get out because the doggone things was too fat. So, just an interesting side information. So, what is an operating system? Well, we all probably think we know all about Windows and Macintosh, but there's a lot more than that. And I don't want to slight the Linux folks, so there's that one also. Think of it as a collection of programs managing all the programs and applications on the computer, allowing us to interact with everything, functions, hardware, software, that we need to perform our tasks. And it's also the basis for how software was developed for that particular operating system. Think of operating systems as consisting of two primary components, the kernel and the shell. Kernel is sort of like the heart where all the processing takes place, and the shell is sort of like the skin where we can interact with the operating system. What's it do? Well, it manages the hardware and software, making it something we can actually work with. It allows us, the users, to interact directly with maybe a graphical or GUI interface or command line interface, a CLI. GUI, of course, is something that we're all familiar with visual interface, mice, scroll bars, buttons, etc. CLI, the Linux folks will be familiar with this. Text-based, back to the old days of DOS for some of us. And there's still a few of them around. It allows for easier system administration, program development, and things like that. You'll notice I use etc. a lot in my presentation because who knows what's going to change tomorrow. So I never propose things are static. What does the operating system perform? What kind of functions? Memory management. It decides which resources and which processes and programs get memory. File management by helping us store our files, accessing and organizing our data. And it processes things into a friendly hierarchical storage system that we should all be able to use. Process management is basically where it prioritizes and monitors the internal processes to make sure everything executes in a proper sequence. Timing is very important to computers and all other technology. It handles the boot up procedures, making sure everything starts in the correct order so the operating system goes to work properly. Most operating systems handle data security to a degree, so they ensure certain processes are executed with the proper privileges. And of course, a user interface, which we talked about, the GUI or the CLI. And they take care of controlling the hardware and software by making sure the two can communicate with each other through, most of us are familiar with drivers for the hardware. Where is the operating stored? Well, in some sort of persistent memory device normally. You don't want to have to type your program in every time, code your operating system, so it's stored somewhere that the machine can find it. It's either internal disk drives, ROM chips, things like that. External, it can be on a USB stick, a memory card, even external hard drives or SSDs. And for those of us that remember the floppies. What are the different types of operating systems? Well, in doing my research, I discovered rather quickly that you can categorize these things in a whole bunch of different ways. So let's talk about some traditional ways. Batch. It's useful for tasks that take a lot of time, use large files, and that's including things like payroll, billing, even some scientific applications. Time sharing, and one thing I want to point out as a side note is many operating systems cross between these types. So don't try to pin them all down. Time sharing is beneficial for multiple users in multiple locations. Think distributed processing for those of us that remember those days. It reduces idle processor time so that the processor is always busy. It provides fast responses to each user. And basically, the users almost believe that they're the exclusive user if the system is set up correctly and not overloaded. And of course, it makes computing a little bit more accessible and affordable. I've seen Unix before. I'm not sure what Multics is. I found that reference to this. Some days I'll look it up. Distributed. This is the ability to process or provide fast data exchange, and it's a very resilient operating system. Connects many machines together in almost like a network operation, but each computer has its own memory and operating system, but it communicates with all other computers to work together. It's used frequently in telecommunication systems, large reservation systems, and things like that. They appear transparent to the users. They don't really know that they're communicating with a large server farm somewhere. Network operating system. Sharing of files and physical devices like printers and scanners, things like that. It is good at handling stability, remote access, common file management, central security, user administration, and even system maintenance. The operating system will handle the communication protocols, all authentication, resource sharing, and authorization on the network. Windows, Linux, and Mac fall into this category. Real time. Best for precise or precision, the prioritizing of timing needed in systems such as air traffic control, weapons control, medical imaging, and things like that. These systems are designed to provide near immediate response to inputs. Mobile operating systems, we're all familiar with our cell phones. They're designed, of course, with mobility in mind. Tablets, anything that we can drag around with us. They're optimized for touch interfaces, power efficiency, so the batteries don't drain too quickly. They handle location services, camera integration, and wireless connectivity. And they're what has made our computing a lot more portable and accessible. Interactive operating systems, they, again, as I mentioned earlier, these systems cross over in various different brand name operating systems. Interactive systems provide direct interaction between users and the system using keyboards, mice, touchscreens, voice commands, things like that. Embedded operating systems, we might not be as familiar with, but they're all around us. These use specialized devices to deliver specific capabilities in areas like automobiles, industrial equipment, smart appliances, etc. And they have formed the foundation of our Internet of Things ecosystem. Again, keeping with the different types of operating systems, there are more ways to classify them. You can classify them by architecture. In other words, what hardware they're going to run on, 32-bit, 64-bit ARM, and a lot of other processors out there. The source code can distinguish the different operating systems. They can be open source, proprietary, and even hybrid. And these fall into the Windows, Mac OS, Linux, FreeBSD, Android, things like this fall into that type of classification. Again, you'll notice these things cross over quite a bit. Processing power. Operating systems can be categorized by the processing requirements they require or they need. Lightweight systems are designed for low power devices and embedded applications. Full feature systems that take advantage of heavy duty, powerful hardware, and specialized systems optimized for specific applications like scientific computing or graphics processing. Gee, how many are there? A lot more than I thought. Windows, of course, we know it's pretty popular. It's pre-installed on the majority of PCs sold today. The Mac OS, Unix-based, probably the second most used today, although I think Linux is starting to push the boundaries there. iOS is a Unix-based mobile partner to Mac, which comes on, of course, the iPhone. Android, we're all familiar with that. It's in our Android smartphones, and it probably comes pre-installed on most smartphones not made by Apple. Not all, but most. Chrome OS, it's a Unix-like, but it's based on Linux, and of course it comes pre-installed on all the Chromebooks. The new Linux system is used a lot in servers, also in embedded markets, and has a significant use on desktops and even smartphones. Popular distributions include Ubuntu, Debian, OpenSUSE, Fedora, and Arch. FreeBSD is a Unix-based system. It's probably the most popular BSD system, and it's used in the production of or as part of companies' products. Apple, Sony, Netflix use it in the back end a lot. NetBSD is another Unix-based. It's general purpose, and it's used on a lot of desktops, and it runs modern browsers, and it has modern desktop environments. OpenBSD, it's a fork of NetBSD. Pardon the pun of the fork on the right. It's also a general purpose OS that can be used on desktops. Dragonfly BSD, another Unix fork of FreeBSD, and it's on the desktop normally. Illumos, a Unix-based system. It's a fork of Solaris 10, and it's had several distributions targeting cloud, NAS, server, and desktop situations. Haiku is a promising alternative, has a broad selection of software, includes a modern browser. It's similar to the old BIOS system that was a failed desktop OS back in the 90s, late 90s, early 2000s. Arca OS is a legacy system that caters to many OS2 users that are still around, apparently. I didn't think there were any. But it's got some significant limitations. It's stuck in the 32-bit arena, which means there's not much hardware left for it to run on. RISC OS is a legacy OS from the 80s, and it was taken open source in 2018. Popular as the desktop OS in the United Kingdom. It's pretty limited, has no support for multi-core, 64-bit, no multitasking, but it has recently apparently received an updated web browser called Iris and has been ported to the Raspberry Pi arena. Amiga OS, many of us remember that from way back when, from the 80s. It was pretty impressive for home users at the time, but again, it's hardware limitation, 32-bit power PC only. It's one browser that's written for Amiga OS is the Odyssey web browser, and it's apparently was still getting updates as of 2022. But that browser is based on a 2019 version of WebKit. MorphOS, and again, it's power PC only, mostly obsolete devices, and can't handle anything over 2 gigabits of RAM. So it appears to be a polished OS, but kind of stuck in the past. ROS. It's an open source re-implementation of Amiga OS 3.1, but there's not a lot of developers for it. However, they believe it could outlive Amiga and Morph because it runs on x86 hardware and it has 64-bit support, which the other ones don't. OpenVMS is a really old operating system. It used to be sold on both servers and workstations, but currently it's pretty well targeted towards the server market, and in particularly the legacy OpenVMS users. The DEC Windows desktop environment, which is its desktop environment, like some of the Linux ports, it's still being developed and still officially supported. It's owned by VSI and was recently, and I don't know how recent, I didn't find a date for this, ported to x86 processors. And its primary focus is as running on a virtual machine as opposed to running on bare metal. One thing I always mention during presentations is when you receive the notes, it's really important to go through the references. A lot of people don't do this, and there's no way I could cover 150 pages of text in a presentation like this. You guys would all be asleep by the time I was done. I'd be hoarse. So please check those references. You'll find a lot of interesting, nostalgic information sometimes. Let's go a little bit more in depth. Some of the more familiar operating systems. Of course, MS-DOS, we all, I think, here remember that, hopefully fondly. Single user operating system, of course, lightweight, allows direct access to everything. If you could write the drivers yourself or find them. It can load data from external sources and run them into internal memory, so everything can be run just fine. Controls and manages everything such as printers, keyboards, and so on and so forth. And it lets us perform input and output and print. Pretty helpful in file management if you understood the way it worked. Some people never figured it out. Drawbacks. No multiple users, no GUI, no multi-programming, only one processor at a time in RAM, or one processor, sorry. No memory protection, less stable, and it didn't do well with over 640 megabytes of RAM, which is hard to remember that used to be considered pretty big. Of course, we move on to Windows. It added the GUI. It runs on x86s, AMDs, and now even ARM, things like that. It was named Windows because of the shape of its windows. I always used to tell my students it was like a window into the computer. But not really, because you couldn't stick your head out and get fresh air. And it was pretty well designed for a range of users from novice all the way up to development by professionals. Again, designed to run on standard processors. So most hardware vendors made drivers for it. It can handle multi-core processors. Comes preloaded with a lot of productivity tools that can help you perform your tasks. Has a large user base, which means there's a lot of development of software programs and utilities. Backward compatible usually. I say that usually because every now and then you stumble across something that isn't. Hardware is usually automatically detected You don't normally have to install device drivers. And of course, it's a network type system, so you can share on a network. Drawbacks. Of course, it's expensive sometimes because you have to pay for the license. And all the applications, typically, there's a lot of free ones, but most of the heavy duty production applications are fairly expensive. Has high resource requirements on the computer. It can get slow and hang up if you bog it down with too many programs at one time, but at least it can run them. And it can be vulnerable to virus attacks because it's such a large user base, and virus writers don't bother spending a lot of time writing viruses for systems that only occupy 1% of the market. When you occupy 95%, of course, they're going to go after it. Linux, open source, freely distributed, cross-platform, developed based on Unix. We all know Linus Torvalds, and it allows us to do pretty much anything we want on the computer. And everybody, I think, thinks or knows it became kind of a symbol of software collaboration. It's free, can be downloaded from the internet, redistributed under the new license, and has excellent community support. It's portable, can be installed on a whole bunch of different devices, multi-user, multitasking system. Bash is the interpreter program that can be used to execute commands. Linux, it provides hierarchical file structure like other operating systems. So that makes it easy to keep track of your stuff for those of us that try. Linux provides security because it has pretty solid authentication features and threat detection. And it's very fast to get that detection out there because the community stays on top of it. Drawbacks. There's no standard edition of Linux, so it's confusing for especially new users when they're trying to figure out which distribution, which desktop, etc. to use. It can sometimes be difficult to find an application that a particular user needs for their support because it doesn't have as large a market as something like Windows. And since a lot of applications are, of course, developed specifically for Windows and Mac, they are not compatible normally with Linux unless the developer has written a Linux version. Some hardware may be incompatible because Linux doesn't have quite the same support for hardware vendors writing drivers. There are plenty of forums to help resolve issues, but some of those forums can get pretty technical and clicky, so the forum members sometimes are kind of rough on newbies, if you want to ask me. Solaris or Sun OS. It's Sun's variant of Unix. It was developed for Sun Spark processors, and also it runs on Intel-based processors. It's scalable, can handle a large workload, and still perform quite well for things like database, web, and Java technology-based services. Most Solaris systems are known for their high availability. They rarely crashed. They were well designed for internet and networking, and they had a lot of features that allowed you to add new features or finding problems or debugging of things that were causing you trouble. A lot of security capabilities, considered in some cases as some of the world's most advanced, user rights manager, cryptographic framework, etc. It comes with tools that allows you to test interoperability, new software, and you can efficiently consolidate your application workloads on it. It's quite expensive because it's an enterprise system, and updates are not free. They lack a good GUI. It's not very user-friendly. And of course, hardware support is not as good as some of the others because it only runs on specific hardware. Plus, it can get really bogged down due to high consumption of the CPU and memory. It'll eat those things up like crazy. Symbian. Some of us might remember Symbian from a few years back. It was discontinued in 2014, and it was at one point the most widely used smartphone operating system. And it was a partnership between people that manufactured both smartphones and PDAs. Designed for low power consumption. It would run on handheld, any kind of handheld digital device. Battery-based devices really loved it because it didn't eat up the battery. And it was designed for ROM-based systems. Its kernel, the EKA2, had preemptive multi-threading, scheduling, memory management, and good device drivers for the hardware it was designed for. It also allowed third-party software. It had a very good user interface. Written, apparently, most of the applications, C++ or the Symbian version of C++, and it had its own SDK. It can run applications written in Python, Java ME, Flashlight, Ruby, and .NET. I'm not a programmer, so I'm talking alien stuff there. Connectivity was good, a lot easier and faster than stuff before it, and was efficient and very stable. And responsiveness was not quite as smooth, a little bit chunky. It was vulnerable to viruses, but I don't recall that many people writing viruses for it. And it had no virtual memory capability. Android. We all love Android, right? Google put this Linux, another fork, if you will, together to run on smartphones and tablets. Can run on ARM, Intel, and MIPS. Android is just basically designed to let you use your mobile device kind of intuitively. Finger motions, pinching, swiping, tapping, kind of comfortable for most of us. It's open source. It's optimized for both 2D and 3D graphics, multimedia, GSM connectivity, and multitasking. And it, of course, has a friendly user interface, but you can customize it quite a bit. A tremendous amount of applications are available. They have their own SDK that you can use to develop your own applications. And it consumes a little bit of power, and it can deliver extreme performance, since a lot of its hardware is based on the ARM architecture. The design and coding of intuitive modern user experiences and interfaces pose a difficulty because of dependency on Java. I'm not familiar with that myself. I don't do programming, so I'm not sure that's still true. The one thing I do know is a lot of apps, most maybe sometimes, tend to run in the background when you think you've closed them, and they can drain the battery. And performance will take a hit if you're running too many things in the background. They can overheat, depending on the phone itself. This is not always an Android problem, but some of them can overheat especially I've found with GPS applications. That can kind of cook them almost. And they have a little bit lower security profile, and you can make you a little bit more susceptible to a data breach. iOS, iPhone OS, of course, developed by Apple, and it's developed exclusively for Apple hardware, similar to the A12 Bionic chip, and that used to power many of its devices. I think it's still on a lot. It, again, gives you a good user interface, touch, swipe, tap, pinch, all that sort of stuff. Written in C, C++, Objective-C, and Swift, which of course is based on the Macintosh OS. Excellent intuitive user interface, and it's very fluid. So one thing about the Apple phones, they seem to be a little bit better responsive than the Android phones. A lot of default applications are available and come with iOS. They have a high availability of higher quality apps because of Apple's insistence on rigid standards for programmers. They have their own SDK for their developers to write applications for their mobile devices. It has a lot better security because of the rigid standards they require their developers to adhere to, so it's a lot safer and has had fewer security breaches. And they, of course, provide regular updates and security patches. Drawbacks. Closed source. So testing of new apps, the programmers and developers can take a little bit longer to get them to market. Memory space. Most applications seem to take up more room than Android and other mobile platforms. There's a little bit less customization of the general operating and interface on an Apple or an iOS device. Doesn't easily allow third-party installations because you got to get them from the Apple Store. However, clever people have figured out ways to bypass that, but they have to work at it. And because of its great graphics and animations, it does cause a little bit more power use and battery drain. Now, into some of the less common systems. FreeBSD, based on the Unix operating system, it's used a lot in server operating systems, but it also can be used on the desktop. It's quite robust and stable, and it's used because of that in a lot of mission-critical applications. It's designed for performance and has advanced memory management and process scheduling algorithms that result in fast and efficient performance. Security, it has a very strong focus on security, has security enhanced kernels, mandatory access controls, and different secure levels. Flexible. It is very flexible and customizable, and users can configure it to meet their specific needs. Has a large repository of software, so people can find what they need. It's designed for networking, similar to other operating systems we talked about, Windows, Mac, and it handles the typical networking protocols. It is a free license, and it is redistributable, similar to Linux. Drawbacks: it has limited hardware support. It may not support some of the latest items out there, latest hardware, like Windows or Mac can do. It's a very complex system because it has so many advanced and technical capabilities. So it takes a little bit more work to set it up. And if you're not very experienced with it, it's going to have to call for some help. It has a smaller user base community than Linux, but it's out there and they're active. But again, since they're smaller, it might be a little bit harder to find support. Chrome, another Linux-based system developed by Google for their Chromebooks. And it's basically a simple and fast web-based, cloud-based type system. It's not really designed for standalone desktop or laptop use. It's fast, has a nice, clean, simple user interface. The majority of the applications are web-based, so you don't have to worry about downloading and installing them. It's integrated tightly with the Google ecosystem, Gmail, Google Drive, Calendar, things like that. You can even get your text messages from your Android phone on your Google device with no problem. Automatic updates. It stays up to date. One thing I will note, I did not put on the notes, but I think most people know that Google has set, just like everybody else out there, a limited lifespan for the Chrome OS. At a certain point, they will stop issuing updates. I think it's at 10 years now, I believe, or 8, something like that. And it's a pretty secure operating system. Again, because it has built-in protection, it has a secure boot function, and the automatic updates help with that. Again, limited offline functionality. It's just not going to do the same things if you don't have an internet connection. While there is a large web-based community of applications, it's not as big as Windows or Mac, but it's still growing. And being web-based, it's pretty easy to set up. They don't have to worry about different hardware compatibility. Limited hardware compatibility. It's designed to work on Chromebooks. I don't know this new operating system they're coming out with. I forget the name of it, but I think it's supposed to spread the hardware dependence out a little bit and make it a little bit more usable on other hardware. And of course, if you're using the Chrome OS, you're going to be pretty heavily dependent on the Google services, which you may not want to do. Mac, proprietary Unix-based system, of course, from Apple. Introduced back in 2001, and now it's the Mac OS X, or rather it's changed from Mac OS X to now just Mac OS. User-friendly, it's got a good graphical interface, and like Windows, it's good for both novices and advanced users. It's integrated within the Mac's ecosystem, so things work really well together. So if you're an Apple fan, then everything is going to function quite nicely. Has a lot of built-in applications, web browser, that sort of thing, iMessage, FaceTime, and you can install a lot of applications, of course, from the Apple Store. And the software that you can get from the Apple Store is usually of high quality because of their exacting standards for their developers. Drawbacks, of course, price. Proprietary, and Mac computers are typically more expensive than the other computers. It's only available on Mac computers. Some people have made it work on other systems with a little fudging. But basically it's limited to the Apple computer systems. The software that you're going to install on it's going to be proprietary and typically only available from the Apple Store. A lot less customization than Windows and Linux. So that might restrict what you think about it and what you can do with it. So in conclusion, understanding operating systems, I think, helps us choose what we need for our specific uses. From a company or a corporate standpoint, of course, batch operating systems and early data processing to the more modern mobile and distributed systems, people continue to develop OSs to make sure they work with modern hardware and serve modern needs. When you're choosing an operating system, of course, most of us are probably going to choose Windows, Mac, or Linux, iOS, or Android, maybe Chrome. But from a corporate standpoint, you're going to have to consider your hardware requirements, what the users need, security considerations, applications, cost constraints, and things like that. So maybe you're going to need a basic embedded system like in your car or in your smart devices, things like that. Everything today seems to have a chip in it. So those operating systems that run on those chips have to be considered for what they're going to do. And the continued development of new and development of existing operating systems makes sure we can use the technology that's around us. Personal computing, enterprise systems, mobile devices, embedded applications, things like that are increasingly more important for all of us. Again, I'm sure as technology advances, operating systems are going to continue to evolve to suit those systems, to suit our needs. And there are probably things that none of us have thought of yet that an operating system and new technology is going to handle. So these are the references. And again, as I mentioned at the beginning, make sure when you get the notes from Judy, you look through these references. Some of them are long and boring, I'll admit that. But quite frankly, some of them are eye-opening that there's that many things out there that we didn't know about. At least I didn't know about them. So that is it. Thank you very much.
A lot of good information that I didn't know about, so I appreciate your presentation.
Absolutely. We did hear about one OS that was around in the 60s. I was having kids in the 60s. What can I tell you? Multics, short for Multiplexed Information and Computing Services, came from Michael and Randy. And it was put together by MIT, Bell Labs, and GE. And the Dayton Microcomputer Association in Dayton has a museum full of old stuff way, way back in the day. And Michael says they have some of the original cards from the GE 645. They have stuff that people haven't thought of in 1,000 years. And Murph says, hey, how about adding the Commodore 64? The OS was in the BIOS, so boot was almost instant. The computer, oh my, only had 64K memory, but lots of games, a word processor, spreadsheet, assembler, basic, modern version of computer available, and a version of Linux emulates it.
Well, I included Amiga.
Right, and I've heard a lot of people say they started out back in the Commodore 64 times. And Murray says BSD equals Berkeley software distribution as of 1994. It was a completely different OS than Unix. And let's see. Chris says, what do you see? Oh, Jolene says the new Chrome OS will be called Aluminum OS, also known as ALOS. Another one of those things in the tech world that makes absolutely no sense at all.
Sounds like a loss.
Yeah, I know. I mean, the takeoff on that is going to be incredible. And Chris says, what do you see as the future of operating systems?
The future?
Yeah.
Well, if you think about it, this is my take on it. If you think about it, we have an operating system inside of us. I don't know what you'd call it. I don't know who programmed it exactly. I think I do. But everything has an operating system if it does something. So it's going to continue to evolve. There are programmers out there with a few smarts that are going to program operating systems or run hardware we probably don't even know about yet.
And that's going to be made out of aluminum. Bill would like to says, do you think that in the future there will be more blurring of the operating systems so that they become interchangeable and cross-platform?
Well, I don't know. That's a good question. I think it might. I mean, the types are blurring across, but the brand names, of course, you're going to have a lot of egos involved and a lot of money involved. So there's always going to be proprietary systems. I don't see Apple ever opening up their system ever. So
really,
never. They'll never do it.
Well, good or bad or indifferent. Thanks for a really cool presentation. I mean, it takes you down memory lane depending upon how long you've been involved in it. And you go, gee, I heard of that one. Never used it. I heard of all of those, but you know, I was just a Windows person. So what can I tell you? John has a comment or a question. You're on.
John.
Hi there. Can you hear me?
Yes.
Okay, a few comments. You said Amiga OS ran on PowerPC platform. That's not correct. It ran on the Motorola 68000 family. Multics, as others mentioned, was developed under sponsorship of the Defense Department. And it was basically, its purpose was to unite and combine features such as multi-user and multitasking that were partly available on mini computers in the early 1960s. No one mini computer offered all of it. Multics required far more CPU speed and more RAM than most computers of the time could make available. It was used only on a few Defense Department mini computers in the 1960s. Oddly enough, in my user group, Pat Ace's one current member, who's now in his 90s, was among the DoD users of Multics. More significantly for us, several of the team of graduate students that developed Multics at MIT then graduated and were employed at Bell Labs. There, they developed a stripped-down version of Multics, which they named Unix. So Multics is the direct parent of Unix.
How about that?
Both the Android OS and iOS automatically take advantage of keyboards and mouse devices if those are connected to the portable Android or OS device. It's quite a treat to see a mouse pointer appear automatically when you connect a mouse device. And finally, in Windows, and this is one of the things that I think makes Windows less efficient than it could be, each application has a kernel in memory devoted to that application. So that means if you run 5 applications, then 5 kernels occupy RAM. If you run 20, then 20 occupy RAM. Can you call it a memory hog? Yes, but it also has had, to some extent, the impact of reducing the cost of RAM because there's been so much demand for it. And that's the end of my comments.
Thank you.
Thanks, John.
Randy?
I just wanted to say that I think the one thing that I realized was missing is the Xerox operating system, which kind of is the predecessor to all of our GUI.
Thank you. Jerry Crow?
Yeah, I worked for Honeywell Information Systems, which bought the GE Computer division, and the Multics developers were. I live here in Arizona, in Phoenix, where Honeywell was, and I got to know a bunch of the Multics developers here and also in Cambridge, and it ran on the GE 645, which was a hardware modified version of their 635 to allow for virtual memory, which was really a big deal in those days. Nobody fully understood, it was very avant-garde and very advanced. And, but yeah, it was expensive and it needed a lot of computer power to run, but it was a beautiful system, beautiful. We tried to convince Honeywell to let go of their mainframe operating system and focus on Multics, but they wouldn't do it and they retired it. So, thank you.
Hey, too cool with the history. Kurt?
Yes, I don't fault Dale for this, but there's another world out there that he didn't cover. My first computer interaction was back in 1968 with an IBM System 360 Model 50, I believe, in college. I earned my living for a lot of years as a systems programmer on what started out as OS MVS to me, and has progressed through the ZOS. These still are considered mainframe computers. And while the hardware that they run on them has been shrunk greatly and increased in power greatly, okay, these operating systems, now called ZOS, still live. They're still powerful. If you've got a checking account, you've probably got information that is going through one of these mainframe systems that still have batch processing in them, extremely powerful, a lot of connectivity, a lot of security, and something that as computer users like this, we never write programs for them, but we certainly interact with them. As an example, if you use an ATM, that transaction is probably going back to a mainframe. And they're connected all the time.
Thank you. Murray?
Okay, I think I'm unmuted now.
You are.
Anyway, my favorite computer back of the, it was too expensive to buy for myself, but I had it work, was the made by Silicon Graphics. The operating system was called IRIX, and it was a form of BSD. And I'll tell you, the keyboard was the nicest keyboard that I have ever had. I wish I could get one of those keyboards, but it was a beautiful computer. And I believe that Linus Torvald first started Linux basically by creating a brand new version of Multics, which became Linux, and he did that as a PhD thesis.
Cool. Thank you very much. And I have a question for all you old geezers that date back to the dark ages. Does anybody work with Mass 11 that was a mainframe word processing program? Nobody, huh?
I don't even know what it did.
Am I the only one in the whole world? It was the best word processing program ever.
Oh, I beg to differ. I think the one that made by Silicon Graphics was the best one ever.
And it was
Judy,
connected
Judy,
to the, I worked
there
at
was a
Spark Aviation in San Fernando Valley. They made bombs. And it was way cool. And then it just went away. And I must be the only one left on Earth that
well,
is.
there was another word processor that I can't remember the name of it that came out around the 70s, and it sort of became a pseudo operating system. But it began as a word processor, and this guy, oh, I can't think of the name of it. Hmm.
Well,
Well, maybe
Mass 11 was put together in the 70s and 80s by Microsystems Engineering.
I sort of remember the name of that, but at FAA we had this other one that was used, and it eventually was on a mainframe, but I can't remember the name of it.
Oh,
was
well,
really
let me know if you do. Gabe Goldberg, you're on.
There are many computer museums around the country for people who feel nostalgic. I think probably the champ is the Computer History Museum in the Bay Area in California. They have just an amazing website, and they have amazing collection, and they do amazing presentations and demonstrations and a gathering of oral histories. And so if folks were interested in today's presentation, Computer History Museum in California is a great resource to look at. There's another much less known museum closer to me, just a little bit north of Baltimore. I can't remember what it's called, but I've been up there for a couple of tours, and they have just a huge exhibit space, and I've donated some stuff from my career. And so if you're on the East Coast, somewhere in the Mid-Atlantic, do a search for Computer History Museum Baltimore or Computer History Museum Maryland, and you'll probably come across it. And I was glad that somebody, after the presentation, mentioned IBM mainframes. There were multiple operating systems for the IBM mainframe that started out as System 360. And I spent my career on the virtual machine. Started out as Virtual Machine 370, VM 370, and now it's up to ZVM. And that is a spectacular time-sharing system. The fact that it's virtual gives each user the impression that they have their own separate, private, dedicated system that they can do anything they want to on, and doesn't affect any of the other dozens or hundreds or thousands of simultaneous users.
Hurry. Jerry Crow, sorry.
I'm surprised no one has mentioned CPM. If I mention that to somebody just study, they'll go, what? But yeah, the first computer I ever owned, a personal computer, was a K-Pro 10, if you remember the K-Pros. And it had a disk drive in it, a hard drive, which was amazing, but it ran CPM, and I did a lot of work on CPM. It was really stood for Control Program / Microcomputer. So anyway.
They're coming out of the woodwork here. Jalen.
Yes, two comments. One about word processing. In 82, I took two classes, an introduction to computer concepts and a word processing course on a DECmate dedicated
You're frozen, kiddo.
process biology to York, and we went to White Plains to the IBM offices. So my first experience with mainframes was in 1967. So long time ago.
I didn't have a kid that year. Okay, so that was good. 66, 68, and 70. 64, 66, 68. Richard Bradford.
Well, first I wanted to ask her to, she faded out. Wi-Fi went a little bit when she started talking about word processing and that class that you took?
It was a deckmate, dedicated word processing computer.
That was my first one after I stopped, closed my parent participation preschool and went out into the real world.
Yeah, Judy,
Glorified typewriter.
my brain fog cleared. The one that I was thinking about was the Wang.
Oh, good God, the Wang. Yes. Oh, I fought with that too.
One of our members was the president of one of our early computer club members here in Hilton Head was the president of Wang.
Wow. Richard Redford, you're
Yes,
on.
I'm glad someone else also mentioned CP/M. That was an early system on micros, but given that the large systems operating systems were mentioned, the best of them was released in 1961 on the big Burroughs MCP. It was an operating system written in Algol, a high-level language, unlike all these others that were written in assembler. And it was very solid, and the people that developed Unix actually based a lot of their ideas on Burroughs MCP operating system.
Too cool. And amazing. Everybody's lived through so much here. It's amazing. Murray, you're the last comment, question, whatever.
Okay, I was just going to say that at Carnegie Mellon University was Carnegie Tech then. The computer that we had was made by Bendix, who were then bought out by Control Data. But that was a beautiful computer system. One thing that was neat about the tape drives on it, and I always wished they'd become the industry standard instead of IBM, because they were generally random access. You could go on their tape, and it was addressable to the point where you could change one bit in the thing, and you didn't have to rewrite the whole block. You just rewrote that one address point. But that was a beautiful computer. And my first, it was, and of course, the main language we used was Algol, and I really liked that Burroughs operating system that was based on Algol. That was really, really neat. So have a great, thank you.
Mr. Dale, I mean, look at the box of worms you opened up here with your presentation.
I know it would.
Everybody's got a story from back in the day. I'm sorry, mine is only about word processing. And I did use the Wang and I hated it with an absolute, oh my God, it was gross. But anyway, thank you for doing that and for letting us talk about all this nostalgic stuff here. Over to you, John.
Yeah, I'd like to thank Dale for, again, presenting to us, and hope we will get him back again in the future. And thanks for all the people that participated and shared that knowledge.